Maybe there isn't such a philosophy.
I think we can broadly follow here what is known about, like, what are the most important examples of models of constructive mathematics, of mathematical worlds, so toposes that are that are not classical, right? And they broadly, you can divide them into two parts: the ones that come from geometry, Grothendieck, algebraic geometry, stuff like that, and the ones that come from computability, so based on some notion of computation. So as a functional programmer, you would be more familiar with the functional programming kind of thinking about constructive mathematics, where you would say things like, well, to prove that for every natural number, there is a prime number that's larger than the given number, okay? It makes sense to write a program which takes a number and outputs a prime larger than it, right? And that's intuitively how you would constructively explain why there are arbitrarily large prime numbers. You wouldn't say, suppose not, right? You wouldn't start with assume there aren't arbitrarily large prime numbers and then derive a contradiction, because, okay, but that doesn't give you any way of actually getting at the prime numbers. So if you keep this idea, if you follow this idea that whenever I claim that something exists, I need to have my little Haskell program that is going to witness the fact that it exists or calculate it or something, then you go into this computational explanation of constructive mathematics that is going to appeal to programmers, more or less, people who are sort of computationally minded in general, who would say, oh, I don't want to just know